Let's have some recapitulation on the amplifier performance. A signal source and a load is connected to a linear amplifier. The output voltage waveform is equal to the voltage gain of the amplifier multiplies the input voltage waveform. If the output is undistorted, that's good performance. If the output is distorted, that's bad performance. Please be reminded that distortion doesn't have to be clipped. In fact, so long as the shape of the output waveform does not resemble the shape of the input waveform, distortion occurs. Let's continue on our recapitulation. Disadvantages of open-loop op-amp. Even a very small input voltage, such as 1 mV, can cause the output of an open-loop op-amp to saturation. This is a negative saturation because the voltage at the inverting terminal is higher than the voltage at the non-inverting terminal now. Here is 1 mV and here is 0 volt only. When the input voltage is changed from positive 1 mV to negative 1 mV, the output voltage is saturated with a positive voltage. The point to take away is that without negative feedback, even a very small input voltage can drive the output to saturation and cause the op-amp to operate in the nonlinear region. Let's carry on the recapitulation. This is a negative feedback loop connecting to the inverting terminal. With the negative feedback loop, Vout will not be saturated. It is because when Vout increases, Vf also increases. When Vf increases, this difference decreases. As a result, Vout will be decreased and not possible to stay in saturation with large amplitude. Therefore, we said, with a negative feedback loop, the closed-loop voltage gain, which is equal to Vout over Vin, can be reduced, and the op-amp can function as a linear amplifier. This is an op-amp with a negative feedback loop. V positive is the voltage at the non-inverting input. V negative are the voltage at the inverting input. As we learned before, the output voltage of an op-amp is equal to the V positive minus the V negative, multiplies the internal voltage gain of the op-amp. This difference is also called the differential input. Since the output voltage has to be limited by the supply voltages, so the output voltage is in the range of the negative saturation voltage to the positive saturation voltage. For example, from negative 36 volts to positive 36 volts. Since the internal voltage gain of an op-amp is very large, let's say 100,000, and this Vout is a small value, so this difference has to be very small, and they are approximately equal. And this approximation will come to be very handy when analyzing operational amplifier with negative feedback. The input impedance of an op-amp can be found in the range of 1 megaohms to 1 teraohms. So we say the input impedance is close to infinity. Since the input impedance is so high, there is very little current can flow into an input terminal of an op-amp. So both of these two input currents are approximately equal to 0. And we will use these approximations for our op-amp circuit analysis later on.